Imagine our solar system as a vast neighborhood, with Earth as our home and other planets as our neighbors. Beyond Earth, Mars glows red, Venus hides behind thick clouds, Jupiter looms as a giant, and Saturn dazzles with its rings. Mercury, the smallest and closest to the Sun, is our most elusive neighbor. Our urge to explore drives us to send robotic spacecraft across millions of miles, braving the dangers of space. These missions are more than technical feats. They're humanity's way of reaching out, asking questions, and seeking our place in the cosmos. But not all journeys are equal. You might think the closer a planet is, the easier it is to reach. Yet, Mercury, despite being nearby, is the Mount Everest of planetary exploration. The real challenge isn't just distance, it's the cosmic forces at play. Getting to a planet is only half the battle. Slowing down enough to stay there is the real test. Mercury's proximity to the Sun makes it especially difficult to reach and orbit. In fact, it takes more energy in planning to orbit Mercury than to reach distant Pluto. The story of exploring Mercury is one of physics, engineering, and relentless curiosity. It's a journey that pushes the limits of what we can achieve, and it all begins with understanding the invisible forces that shape our solar system. Gravity is the invisible force that shapes the universe, keeping planets in orbit and our feet on the ground. The Sun's immense gravity acts like a cosmic anchor, holding the planets in a delicate balance of speed and pull. When we launch a spacecraft, it's already racing around the Sun with Earth at 67,000 miles per hour. To reach outer planets like Mars or Jupiter, we speed up, pushing into a larger orbit. But heading inward, toward Mercury, is a different challenge. To get there, we must slow down. Counterintuitive, but necessary. As a spacecraft approaches the Sun, gravity pulls it faster and faster, like a ball rolling down a steep hill. By the time it nears Mercury, it's moving at breakneck speed. To enter orbit, we have to slam on the brakes, a nearly impossible task in the vacuum of space. There are no air brakes, only rocket engines, and slowing down requires enormous amounts of fuel. This is why Mercury is so hard to reach. The Sun's gravity accelerates our spacecraft, and Mercury's weak gravity offers little help in capturing it. The closer you get to the Sun, the harder it is to stop. Visiting Mercury isn't just about traveling across space, it's about mastering the cosmic dance of gravity and speed. Every mission to Mercury is a battle against the Sun's relentless pull, and that's what makes it one of the greatest challenges in planetary exploration. Mercury sits right next to the Sun, deep in the solar system's gravity well. Sending a spacecraft there is like rolling a marble down a funnel. The closer it gets, the faster it moves. By the time a probe reaches Mercury, it's racing so fast that the planet's weak gravity can barely catch it. Slowing down enough to enter orbit requires a massive braking burn, but carrying that much fuel is nearly impossible. The Sun's heat adds another layer of difficulty. Spacecraft near Mercury face searing temperatures on one side and freezing cold on the other. They need advanced sun shields and thermal systems just to survive. Mercury's small size and weak gravity mean there's little margin for error. It's like trying to catch a bullet with a butterfly net. Every gram of fuel and every degree of heat matters. The combination of intense gravity, extreme temperatures, and limited resources makes Mercury the ultimate test for spacecraft. Only the most carefully engineered missions can hope to succeed. That's why reaching and orbiting Mercury is considered a pinnacle of space exploration. It's a challenge that pushes our technology and ingenuity to the limit. And it's a challenge we've only recently begun to overcome. If we can't carry enough fuel to slow down at Mercury, how do we get there? The answer: gravity assists. By flying past planets like Earth and Venus, spacecraft use their gravity to change speed and direction, like a cosmic slingshot. For Mercury missions, the goal is to slow down, not speed up. Multiple flybys are needed, each one carefully planned years in advance. The Messenger mission, for example, performed 6 flybys, 1 of Earth, 2 of Venus, and 3 of Mercury, before it could finally enter orbit. Each flyby is a precise maneuver. A small error could ruin the mission. This winding, years-long journey replaces the need for massive fuel tanks with clever navigation. Gravity assists turn the solar system into a giant pinball machine, guiding our probes to their targets. It's a brilliant solution to a seemingly impossible problem. Without this technique, orbiting Mercury would remain out of reach. Our first close look at Mercury came from Mariner 10, launched in 1973. Using a gravity assist from Venus, Mariner 10 became the first spacecraft to visit Mercury. Its flybys revealed a world that looked like the moon, cratered, ancient, and mysterious. Mariner 10 discovered Mercury's thin atmosphere and surprising magnetic field. It wasn't designed to orbit, but its unique path allowed 3 flybys, mapping nearly half the planet. The mission pioneered the gravity assist technique, setting the stage for future exploration. Mariner 10's images and data transformed our understanding of Mercury. It showed us a world of cliffs, scarps, and a shrinking surface, and it left us with more questions than answers. For decades after Mariner 10, Mercury remained largely unexplored. Enter Messenger, launched in 2004, with a mission to orbit and study Mercury in detail. Its journey took nearly 7 years, using 6 gravity assists to slow down enough for orbit. In 2011, Messenger became the first spacecraft to orbit Mercury. Protected by a special sunshade, it survived the planet's extreme heat. Over 4 years, Messenger mapped Mercury's entire surface, studied its magnetic field, and found water ice in shadowed craters. It revealed a planet with a strange, dark surface and a unique composition. Messenger's discoveries rewrote what we knew about Mercury. When it ran out of fuel in 2015, it ended its mission with a final descent, leaving a new crater as its legacy. Messenger proved that with patience and ingenuity, even the toughest worlds can be explored. Its data continues to shape our understanding of the innermost planet, and it paved the way for the next generation of Mercury explorers. Compared to Mercury, reaching Mars and Venus is much more straightforward. To get to Mars, we speed up and use a Hohmann transfer orbit, a fuel-efficient path that takes 6 to 9 months. Mars's stronger gravity and thin atmosphere make it easier to capture incoming spacecraft. Aerobraking in the Martian atmosphere helps slow down, saving fuel. Venus, though closer to the Sun, is still easier to reach than Mercury. Its gravity is nearly as strong as Earth's, making orbital capture simpler. Venus's thick atmosphere allows for effective aerobraking, just like at Mars. The journey to Venus is shorter and requires less energy management. These factors make Mars and Venus more accessible for orbiters. Mercury's small size, weak gravity, and proximity to the Sun make it uniquely challenging. That's why so many missions have visited Mars and Venus, while Mercury remains a rare and difficult prize. Each planet presents its own challenges, but Mercury stands alone as the toughest to orbit. And that's what makes its exploration so remarkable. Mercury is a planet of extremes: fastest orbit, slowest rotation, and wild temperature swings. A year on Mercury lasts just 88 Earth days, but a single day-night cycle takes 176 Earth days. The Sun appears huge in Mercury's sky, rising, pausing, even moving backward before setting. Daytime temperatures soar to 430 degrees C, 800 degrees C, while nights plunge to 180 degrees C, 290 degrees C. Despite the heat, Messenger found water ice in craters near the poles, hidden in perpetual shadow. Mercury's core is massive, about 85% of its radius, making it a giant iron ball with a thin rocky shell. One theory suggests a colossal impact stripped away much of its outer layers, leaving the dense core. Its surface is scarred by cliffs and ancient craters, recording billions of years of history. Mercury's unique features make it a key to understanding how rocky planets form. Every discovery there challenges our assumptions about the solar system. It's a world of fire, ice, and iron, unlike any other. And it still holds many secrets waiting to be uncovered. Why do we go to such lengths to explore Mercury? Because every planet is a piece of the cosmic puzzle. Mercury's strange core and surface offer clues to the solar system's violent beginnings. By studying it, we learn about the forces that shaped all rocky planets, including Earth. The quest isn't over. The Bepi-Colombo mission, a joint effort by Europe and Japan, is on its way to Mercury now. It will build on Messenger's legacy, using 2 orbiters to study the planet in unprecedented detail. Each mission pushes the boundaries of our knowledge and technology. Exploring Mercury is about more than science. It's about human curiosity and the drive to understand our place in the universe. These journeys remind us that we are part of something vast and wondrous. The challenges inspire us to be more creative, more determined, and more united. And as long as questions remain, our journey of discovery will continue.